In this video, we're going to continue to look at what a logarithm is, and we're going to be looking at specifically the fact that a logarithm is just the inverse of an exponential, and how we undo them, and just trying to find some different pieces with it. Before we get into really what a logarithm is, what I would like you to do is I want you to spend as much or as little time as you want on this, trying to figure out what each of the blanks are underneath. There are some that are super easy, they're nice integer values, and others that are much more difficult. So what I'm going to do is I'm going to pause it, I'm going to have you guys pause it, and come up with as many of these as you can. So I filled in a few more integer values just to give you a feel for what it is. So hopefully you've kind of checked your work and see, oh, nope, I had the wrong idea. Or, oh, no, I'm doing pretty good. There's a few more that have nice integer values, but pause it again and see if you can find a few more of them. So 64 is 6. 2 is 1. 1/8 is -3. This one is a nice value. It's a fraction, but it's still a nice value. This one's an integer. And this one's an integer. The other ones are going to be a little bit more challenging, and you might have to see the relationship amongst them. So see if you can find those last three if you haven't found those yet. So 1 is 0. 0.25 is the same thing as 1/4. Therefore, that's -2. And the square root of 2, if you remember the square root of 2, that's the same thing as 2 to the half power, because that's a half. Okay, so what's the relationship? X equals 2 to the y. X equals 2 to the y. So now what I want you to do is, with a little bit of guess and check, I want you to figure out the last 4. I've purposely left those last. Two of them are super odd. The other 2 are pretty straightforward. So again, an X is 3. You are going to have to guess and check, legitimately guess and check, to figure out what y is. Okay, so go ahead and guess and check those last 4. So for 3 is approximately 1.6. That is a positive 1.6. Let me try that again. I'm just going to put 1.6. I just don't have the space. And then for 0.2, it is -2.3. Now let's look at these special ones, 0 and -1. So 0 equals 2 to the y. 2 times itself how many times? Or 2 to what power is 0? Nothing. There is nothing. I can't take 2 to any power and get a 0. If I take 2 to the 0, I get 1 out. And then the last one is -1. 2 to what power gives me a negative? I can't take a positive base and take it to a power and get a negative number out. Even if I tried to give it a negative exponent, remember, a negative exponent just changes its location. So if I took 2 to the negative first, it's the reciprocal. That's 1/2. It's not negative, it's still positive. So therefore, at -1, there is no value there either. Okay, second one. Oh, sorry. One other thing. So we said this is 3 equals 2 to the y. 3 equals 2 to the y. So rewrite that based on what we just learned the other day. Rewrite that so that my y value is no longer an exponent. And what do I mean by that? We know logs. What is a log? A log, by definition, is an exponent. Remember, a log is an exponent. So therefore, what is my base? The base of my exponential is the base of my log. That 2 has to be subscripted. Make sure you drop that 2. And then the 3 is what goes right here. So 2 to the y equals 3. Okay, so that is just a log. So I could go through and make a table for this and graph it and that sort of thing, which is what we're going to be doing in the next one. So very similar situation. In this case, I'm telling you the equation. This is y equals log base 5 of x. So if you would, I would like you to fill in as many of these as you can. Some of them are easy. Others of them are a little bit more difficult. You may have to do some guessing and checking. You might see some patterns along the way. My recommendation to begin with is rewrite this. So go ahead and rewrite it. So rewriting this is 5 to the y equals x. Okay, remember, a log is an exponent, which is why y is the exponent on my 5. So I just rewrote it. They are exactly the same thing. They are completely equivalent. So now that it's in this form, maybe it'll help you fill in some of those values in your table. Go ahead and pause this. I'll fill them in as you're working. Okay, so those are the table values that we have. Just check your work just to make sure. Sorry, some of them are kind of messy. But one of the things that I want you to see is as x is increasing. So x keeps getting bigger and bigger. So these are in order. As x is increasing, what's happening to your y values? They're also increasing. They're just increasing slowly. Because with a log graph, that's what we have. We have that slow growth. Whereas if you think about an exponential function, as x increases, y increases very quickly. Whereas for a log function, as x increases, y increases slowly. Again, keeping in mind we may have some transformations and such as well. So what we're going to look at now is the graph of this function. Okay, we are going to look at the graph of 5 to the y log base 5 of x, or which is 5 to the y equals x. So that's what we're going to first look at, and we're going to compare that to its inverse. So again, y equals log base 5 of x. So I just took my table from before, and I just plotted these points. You don't have to graph this, but just take a look at what we have. So we have this graph. This is equivalent, so I'm just going to rewrite this as 5 to the y equals x. Come on. So these are equivalent. All 4 of these things are exactly the same thing. This equation, this table, and this graph. All 4 of those are the exact same thing. Now what we're going to look at is how does that graph compare to y equals 5 to the x? The inverse. Is a graph and its inverse the same? No. A graph and its inverse, their tables, the x's and y's switch. Their graphs reflect over the line y equals x. They are not the same. So you need to be careful so that you don't think they are the same. So therefore, this is the inverse. See how I interchanged my x and y? Here it was x equals 5 to the y. Here it's y equals 5 to the x. These are not the same. They are not the same. They are inverses of each other. So therefore, when I graph this table, so I've made the inverse table for this, I am going to get completely different graphs. Specifically, this graph here. Oops. Something like that. So these graphs are not equivalent because the equations are not equivalent. They are inverses. So when I graph that line, let's try that again. When I graph that line y equals x, they should reflect over it. This is where students will start to struggle with logs and exponentials, figuring out when are they equivalent and when are they inverses. So remember, the equivalency piece, I tried to keep them kind of all colorful for you to keep track of that. The equivalency part is rewriting from exponential form into log form. These are equivalent. Okay, these are just rewritten. Remember how we learned about rewriting in chapter 3? We talked about equivalency and like how do I rewrite different things by expanding, rewriting, undoing. Now we're going to be looking at equivalency with just exponential form versus log form. If I interchange x and y, those are no longer equivalent. I switched x and y. However, when we're just rewriting from exponential form to log form, those are equivalent. Okay, so a little bit more practice on just rewriting logs. This is based off of the video from the other day. being able to think through the equivalency piece, and then the hope is that in 72 that you don't have to always rewrite them into exponential form. Sometimes it's helpful too, but we want you to start seeing some patterns as well. Okay, so pause the video, do 70. I'll go through the answers to those, and then do 72, and then I'll talk about the answers to those as well. So I wrote all the answers to each of the problems in the black, and it said rewriting the equivalent exponential form, just to show, hey, these do work, and then it's a nice way to double check your work, just to make sure that you don't make any silly mistakes along the way. So now in 72, what our goal is instead of rewriting them, instead we can say 7 to what power is 49? Okay, so instead of rewriting it, 7 to the question mark equals 49, you're just legitimately thinking through it. Well, 7 to what power is 49, etc. So think through all of those and go ahead and answer those. So therefore, 7 to what power is 49? That would be 2. 3 to what power is 81? That's 4. 5 to what power is 5 to the 7th? That's 7. Isn't that kind of an easy one? Like when you actually think it through. 10 to what power is 10 to the 1.2? Well, that has to be 1.2. And then 2 to what power equals 2 to the w plus 3? Odd, but it's just w plus 3. Quick note, something to kind of look forward to as we start looking at some log properties, which we're going to get to in chapter 6. See how the base here and the base of the exponential part, even though it's in the argument, is the same. The answer is just your exponent. Same thing here, same thing here. That's only because the base of the log and then the base of the argument were both the same. So again, just a nice organizational tool for you. Nice job.